Hey everyone, and welcome back. Today we're taking a really close look at an explainer covering a project that has absolutely sent shockwaves through the database engineering community. We are talking about PGRUST. Now, if you've ever worked with databases, you know that PostgreSQL is basically the undisputed heavyweight champion of the open source relational database world. I mean, it's reliable, it's incredibly feature-rich, and it is heavily battle-tested. But what happens when you take that decades-old, legendary C code base and completely rewrite it from the ground up using one of today's absolute favorite programming languages? Well, that's exactly what we're getting into today. We're going to unpack this monumental rewrite of legacy infrastructure step by step.
Okay, let's dive into this. Here is our roadmap for today. We'll start with rebuilding Postgres in Rust, then look at passing the ultimate test, explore a new threaded architecture, check out some massive performance gains, and finally wrap up with the future of PGRUST.
Let's kick things right off with Section 1, Rebuilding Postgres in Rust.
So, PGRUST is pretty much exactly what it sounds like. It's a complete, incredibly ambitious rewrite of the Postgres database. But you know, the how is honestly just as fascinating as the what here. This project leverages Rust, which is famous in the developer world for its memory safety, its concurrency features, and just blazing speed. But let's be real, rewriting millions of lines of legacy C code by hand, that's a nearly impossible task. So the developers are actually utilizing modern AI-assisted programming tools to help translate and rebuild the whole system. They're basically letting AI do the heavy lifting of code translation, which frees up the human engineers to explore deep, fundamental changes to how the server actually operates. And they're doing all this while keeping the final product completely Postgres-shaped.
Now, what's really interesting here is this direct quote from the developers that reveals the true objective. The goal isn't just to, use a trendy new language for the fun of it. The primary objective is literally to make Postgres easier to change from the inside. Think about it. Traditional Postgres is an absolute tank. It's bulletproof. But because of its age and that C-based architecture, making foundational changes to its core mechanics can be incredibly daunting. It's risky. By porting it to Rust, they are laying down a modern, safe foundation that lets them experiment with radical new architectural designs without breaking the core behavior that we all rely on.
That brings us to our second section, because look, an ambitious rewrite is really just a fun experiment until it can actually prove itself. So let's look at Section 2, Passing the Ultimate Test.
Check out this massive number, 46,000. In the database world, correctness is quite literally everything. Honestly, nobody cares how fast or modern your database if it occasionally corrupts your data or returns the wrong query result, right? Well, 46,000 represents the number of regression queries where PGRUST perfectly matched the expected standard Postgres output. We're talking tens of thousands of complex edge cases, super-specific data types, and complicated joins where this completely new Rust rewrite behaved exactly like the original C-based Postgres. No differences.
So the crucial point is that this isn't just some prototype anymore. It's demonstrating real foundational credibility. PGRUST has hit a 100% pass rate on the Postgres regression test suite. Right now, it's actively targeting compatibility with the upcoming Postgres version 18.3. But honestly, perhaps the most mind-blowing point is that last one. It is completely disk compatible. That literally means you can take a standard Postgres 18.3 data directory, like the actual physical file sitting on your hard drive, point PGRUST at it, and it'll just boot right up. It reads the exact same binary format on disk. This completely disarms the usual skepticism you hear around database rewrites, because it essentially treats the real Postgres as the absolute oracle of truth.
So if it acts like Postgres and reads the same files as Postgres, what is actually different? Let's move to Section 3, a new threaded architecture.
And this brilliantly illustrates the fundamental engineering shift happening inside this project. It all boils down to processes versus threads. Traditional Postgres relies on what's called a process per connection model. That means every single time a new client connects to the database, the operating system has to fork a whole new heavyweight process. Now, it's incredibly stable for sure, but it eats up a lot of memory, and managing thousands of those processes gets wildly inefficient. PGRUST totally flips the script. It uses a thread per connection model. Because Rust just makes safe multi-threading so much easier to implement than C does, PGRUST can handle connections using really lightweight threads inside a single process. This is a massive structural departure from how Postgres has operated for literally decades, and it paves the way for a significantly leaner, highly scalable engine.
Of course, architecture changes aren't just for academic theory, right? We want to see real-world results. Let's shift over to Section 4, Massive Performance Gains. We are seeing a staggering hockey stick spike in performance here. Starting with baseline Postgres as our 1x standard, the new architecture in the unpublished work-in-progress version of PGRUST accelerates transactional workloads to 1.5x. That's your standard inserting, updating, and deleting of rows, getting a 50% speed boost straight out of the box. But look at the analytics side. For analytical workloads, where you're scanning huge amounts of data for aggregations and reports, PGRUST is running an unbelievable 300 times faster than standard Postgres. 300. That is a completely paradigm-shifting number for developers who usually have to go through the headache of exporting their Postgres data into a totally separate data warehouse just to run some reports.
Just to keep things grounded, though, how does that 300x analytical speed compare to tools built specifically for analytics? Well, when put up against ClickHouse, which is pretty widely considered the gold standard for lightning-fast database analytics right now, PGRUST is currently running about 2 times slower on the standard ClickBench benchmark. But here's the exciting part. The PGRUST team firmly believes they can eventually optimize their engine to be even faster than ClickHouse. Just imagine having the supreme reliability and the deep familiarity of Postgres, but paired with the analytical reporting speed of a dedicated data warehouse, all sitting right there in one single system.
Which brings us to our final segment. Section 5, the future of PGRUST.
First, we absolutely need a vital status check to ground ourselves. PGRUST is very much an experimental project, and it is explicitly not production-ready yet. While they're getting incredible speed in their internal versions, the publicly available codebase isn't fully performance-optimized just yet. Plus, if you rely heavily on existing Postgres extensions, specifically procedural languages like PL Python, Perl, or TCL, those just aren't generally compatible right now. So definitely do not go ripping out your company's production Postgres cluster today to replace it with PGRUST. But let's look at how this new foundation builds a really ambitious vision for the roadmap. Look at the immense quality of life improvements the developers are targeting here. Because they're building on this new Rust foundation, they plan to introduce built-in connection pooling. That would completely eliminate the need for third-party tools like PG Bouncer. They are exploring no vacuum storage designs, and hey, if you are a database administrator, you know that avoiding the dreaded Postgres vacuuming process is pretty much the holy grail. They're also planning runtime guardrails to catch bad AI-generated SQL queries before they crash your system, alongside better JSON support and far more stable query planning. They are systematically going down the list of every classic Postgres headache and engineering a modern solution.
As we wrap up this explainer, I want to leave you with a somewhat provocative thought. When a project can take a 40-year-old foundational technology, rebuild it entirely in a modern language, achieve 100% test compatibility, and simultaneously unlock 300x performance multipliers, is a Rust-based future inevitable for all our legacy databases? The success of PGRUST strongly suggests that the next era of database engineering won't be about inventing entirely new databases from scratch, but rather radically upgrading the ones we already know and trust. Thanks so much for exploring this with me today, and keep learning.